Good day, everyone. I am Christian R. Basilio under the supervision of Mr. Ivan Mark S. Sigua. And for this day, I will be presenting my thesis entitled Development and Validation of Multimedia-Based Instructional Module in Science 7. So to begin with, let us have the background why I initiated this study. So one of the initiatives of the government to strengthen the basic education system in the Philippines is the promulgation of Republic Act 10533 or the Enhanced Basic Education Act of 2013. This law paved a way for the implementation and development of the K-12 program, wherein one of the main goals of the K-12 program is to produce productive and responsible citizens empowered with the necessary competencies, skills, and values needed for lifelong learning, employment, and the challenges of the 21st century. One of the subjects under the K-12 program is science. At the end of the entire science curriculum, the learners are expected to demonstrate an understanding of basic science concepts, apply science inquiry skills, and exhibit scientific attitudes and values. In line with the implementation of the K-12 program, the science curriculum has undergone educational reforms and innovations. Science as a subject is now taught in a spiral progression approach. This means that the level of complexity of each science concept increases as the learners move from one grade level to another. This design provides the learner with a deeper understanding and mastery of core concepts after each level. In terms of instruction, the science curriculum shifts from traditional methods of teaching to a learner-centered and inquiry-based methods of teaching, which aims to enhance the critical thinking and scientific skills of students. However, despite of these innovation and educational reforms, the goals of science education seems arduous to be achieved. This can be reflected by the poor results of international and national standards assessments conducted on Filipino learners such as National Achievement Test, DOSC Scholarship Examination, and the Program for International Student Assessment, among others. This poor performance of students has stimulated researchers to identify the different factors attributed to low academic achievement. Some of these factors are the following: lack of learning facilities, lack of instructional materials, and the teacher's lack of knowledge in instructional material development, and inappropriate and one-size-fits-all use of instructional materials and strategies in teaching different types of learners. To resolve this issue, Section 10.3 of Republic Act 10533 mandates the production and development of locally produced teaching and learning materials. Similarly, the Department of Education stated that there should be a sufficient production of relevant, appropriate, and contextualized supplementary materials to support and supplement the use of course textbook. Furthermore, DepEd Order Number 35 Series of 2016 encourages teachers to enrich the teaching and learning process by integrating strategies utilizing ICT that are developmentally appropriate. To add, the development of instructional materials such as module is an imperative in the realization of DepEd's basic education learning continuity plan in light of the COVID-19 public health emergency. Particularly, these modules can be used in the implementation of modular distance learning. Modular distance learning allows students to use printed or digital self-learning modules and other learning resources. To define, a self-learning module is a learning material that contains planned series of learning activities designed to help students to achieve a set of objectives. Different researchers asserted the advantages of self-learning modules in the field of education. Nardo and Hofana 2014 stated that self-learning modules support independent study and students are learning how to learn. Moreover, the study of the media and Kanchan 2014 concluded that the use of self-learning modules create an effective learning environment for learners to learn and provide immediate feedback on the performance of the students. Furthermore, Lim 2016 asserted on his study that self-learning modules enable students to develop individual learning study habits. And now let us talk about the role of multimedia in learning. Multimedia in the context of education refers to the learner's construction of knowledge from words and pictures. Mayer 2017 stated that multimedia learning represents powerful technology designed to enhance human learning. Cheng, Safon, Basu, and Gobel 2010 stated that the use of multimedia in learning promotes creative thinking and engagement to the students. Furthermore, Aquinoso 2018 stated that multimedia learning encourages deep reflective thinking. Based on the cited literature, it is evident that there is a problem in the academic achievement of science learners in the Philippines. It is also found out that the utilization of modules has a positive impact on the academic performance of the students by supporting and supplementing the learning process. Furthermore, it was also conferred by the researchers that applying technology and multimedia in the teaching and learning process enhances the academic achievement of the students. Hence, it is for this reason why the researcher prodded to develop a multimedia-based instructional module in Science 7, which aims to improve the academic performance of students in Science 7. Furthermore, the development of a multimedia-based instructional module in Science 7 is also a response to the call of the Department of Education in ensuring the continuity of learning despite the challenges of COVID-19. Let us now proceed with the research problem of the study. This study generally aims to develop and validate a multimedia-based instructional module in Science 7. Specifically, it intends to answer the following question. Number one, how may the multimedia-based instructional module in Science 7 be developed? And number two, how may the multimedia-based instructional module in Science 7 be validated in terms of content, design or format, technical or technological aspects, and pedagogy? To attain these research objectives, the following methods of research were utilized. This study utilized quantitative this study To attain these research objectives, the following methods of research were utilized. This study utilized quantitative methods of research using descriptive approaches of research in developing and validating the multimedia-based instructional module in Science 7. It is also a developmental research. And then this study consisted of three sets of evaluators. The topics included in the multimedia-based instructional module was determined by 10 Science 7 teachers who have experience in teaching Science 7 for 3 years or more. The content and pedagogical aspect of the multimedia-based instructional module was validated by 5 science experts. Meanwhile, the design or format and technical or technological aspect of the multimedia-based instructional module was validated by 5 LRMDS and ICT experts. Purposive sampling of research was used in determining the three sets of evaluators. The evaluation instrument for topics to be included in the distance education and open distance e-learning module was utilized in figuring out the content validity of the topics included in the multimedia-based instructional module in Science 7. On the other hand, the evaluation rating sheet for distance education and open distance e-learning modules was utilized in validating the developed module. These two instruments were developed by the experts of the College of Education of Pampanga State Agricultural University. To analyze the data of the study, the following statistical tools were used. The content validity ratio formula developed by Loshi was used to determine the content validity of the learning competencies included in the multimedia-based instructional module. Meanwhile, frequency and percentage were employed in analyzing the validation ratings of experts on the multimedia-based instructional module. Let us now proceed with the results of the study. For research objective number one, how may the multimedia-based instructional module in Science 7 be developed? Based on the curriculum guide in Science of the Department of Education, there were 45 learning competencies in Science 7. In this study, out of 45 learning competencies, only 32 learning competencies received a CVR value that are greater than the minimum value of CVR for 10 experts, which is 0.62. This means that these 32 learning competencies are considered essential and will be included in the module. On the other hand, 13 learning competencies did not, on the other hand, 13 learning competencies did not receive a CVR that is greater or equal to the minimum value. This means that these learning competencies are not essential and will not be included in the module. For the first quarter, the not essential learning competencies as reflected in Table 1.1 are the following. First, investigate properties of acidic and basic mixtures using natural indicators, and describe some properties of metals and non-metals such as luster, malleability, ductility, and conductivity. For the second quarter, the not essential learning competencies as reflected in Table 1.2 are the following. Identify parts of the microscope and their function. Focus a specimen using the compound microscope. Describe the different levels of biological organization from cell to biosphere. Then describe the process of fertilization. And last one, predict the effect of changes in abiotic factors on the ecosystem. For the third quarter, the not essential learning competencies as reflected on Table 1.3 are the following. Describe how organisms produce, transmit, and receive sound of various frequencies. Describe the different types of charging process and explain the importance of earthing or grounding. And lastly, for the fourth quarter, the not essential learning competencies as reflected on Table 1.4 are the following. Using models, relate the tilt of the Earth to the length of daytime, the length of daytime to the amount of energy received, the position of the Earth in its orbit to the height of the Sun in the sky, the height of the Sun in the sky to the amount of energy received, the latitude of an area to the amount of energy the area receives, and then show what causes changes in the seasons in the Philippines using models, and collect, record, and report data on the beliefs and practices of the community in relation to eclipses. So based from the results, it is concluded that the multimedia-based instructional module in Science 7 was developed using the learning competencies marked essential by the evaluators. Based on this, it is recommended that the future researchers may use a questionnaire with a rubric that contains specific criteria in evaluating the learning competencies as essential or not essential. Let us now proceed with research objective number 2. How may the multimedia-based instructional module in Science 7 be validated in terms of content, design or format, technical or technological aspect, and pedagogy? Let us first talk about the validation of expert in terms of content. Table 2.1 shows the evaluation of experts on the content of the multimedia-based instructional module in Science 7. 5 or 100% of the evaluators agreed that the module met all the criteria that is included on the first factor, which is content. This means that the developed instructional module contains lessons that are in line with learning competencies in Science 7. The information presented are important, adequate, accurate, free from errors, and presented in language that is suitable to the level of grade 7 students. Next, let us now proceed with the evaluation of experts in terms of design or format. Table 2.2 delineates the evaluation of experts on the design or format of the multimedia-based instructional module in Science 7. 5 or 100% of the evaluators agreed that the module met all the criteria that are included on the second factor, which is design or format. This means that the textual information are presented using appropriate font size and font style. Proper spacing, margin, and indentation were also observed in presenting the information. Moreover, the multimedia elements used in the module are relevant to the topics and are motivating. Furthermore, the module is also properly organized and packaged. Let us now proceed with the technical or technological aspect of the module. Table 2.3 presents the evaluation of experts on the technical or technological aspect of the multimedia-based instructional module in Science 7. 5 or 100% of the evaluators agreed that the module met all the criteria that are included on the third factor, which is technical or technological. The results mean that the multimedia-based instructional module can be used using an application that easily downloaded by the student. It also has a user-friendly interface and navigational tools that even novice users can easily follow. Let us now proceed with the pedagogical aspect of the module. Table 2.4 presents the evaluation of experts on the pedagogy of the multimedia-based instructional module in Science 7. 5 or 100% of the evaluators agreed that the module met all the criteria that are included on the fourth factor, which is pedagogy. This means that the learning objectives found on the multimedia-based instructional module are clearly stated and they provide information to the students on what is expected of them at the end of each lesson. The multimedia-based instructional modules also consist of learning activities that are parallel to the learning objectives. It also consists of assessment tools that promotes higher order thinking skills, and furthermore, the result also denotes that the multimedia-based instructional module provides good feedback mechanisms to students in tracking or checking their progress. Based on these results, it is concluded that all of the evaluators agreed that the multimedia-based instructional module in Science 7 met all the criteria found in each factor on the instrument, namely content, design or format, technical or technological, and pedagogy. Based on this conclusion, it is recommended that to conduct a study that will research the effectiveness of the developed multimedia-based instructional module by implementing it. Also, the perception of the Science 7 learners about the multimedia-based instructional module can also be considered to get feedback in improving the module based on their experience in using it. And that ends my presentation. Thank you for listening. Dakalpong salamat.